Hey guys, Mr. Backerberg here. In this video, we're going to revisit speed. So if we're talking about an object's average speed or average rate of change, that's the change in position over a given period of time. And if we think about this visually with a graph, the average speed or average rate of change relates to the slope of a secant line through a couple of given points. Now, if we compare that to an object's instantaneous speed or instantaneous rate of change, it's the speed or rate of change at a specific time. So visually, if we think about this as a graph, the instantaneous speed is the slope of the tangent line at that given time or at that given x value. So in this example, we're going to find the instantaneous rate of speed for the function f of x equals 2x squared minus 1, and we're going to find that at an x value of 2. So to find the slope of this tangent line, we're going to do the limit as h approaches 0, and we're going to look at f of x plus h minus f of x all over h. So if we're looking specifically at an x value of 2, then really what we're going to be looking at is f of 2 plus h minus f of 2 all over h. So if we're doing f of 2 plus h, that says plug in 2 plus h to that function. So this is going to be 2 times 2 plus h squared minus 1. And then we're supposed to subtract off f of 2. So we're just going to plug in 2. 2 squared is 4, times 2 is 8, minus 1 is 7. So f of 2 is 7, and this is all over h. I'm going to start by combining the negative 1 and the negative 7 on the back end. So we have 2 times 2 plus h squared minus 8 all over h. We should work on squaring that binomial in there. So 2 plus h squared really means times another 2 plus h. So we're going to have 2 times 2 is 4, 2 times h is 2h, h times 2 is another 2h, and then h times h is h squared, and then we have minus 8 on the back end, and this is all over h. I'm going to distribute that 2 in, so 2 times 4 is 8, 2 times 2h is 4h, 2 times this other 2h is another 4h, and then 2 times h squared is 2h squared, but then we still have this minus 8 on the back end, and this is all over h. Looking at combining some of those like terms on the top, 8 and negative 8 cancel each other out. 4h and 4h makes 8h plus 2h squared in the numerator, and in the denominator we still have h. We can factor out an h on the top, so that's going to be h times 8 plus 2h all over h. These h's on the outside are going to cancel each other out, so we get 8 plus 2h. But we're not quite done, because now we need to do the limit of this 8 plus 2h as h is approaching 0. So if I direct substitute 0 in there, I just get 8 as my answer. So the instantaneous rate of change, or the instantaneous speed of this function at the x value of 2 is just 8. In this example, we're going to look at the distance an object is falling. So that can be modeled using the function y equals 16t squared. So we're going to find the speed of a falling rock at a time of 1 second. So again, we're going to look at doing the limit as h is approaching 0 of f of x plus h minus f of x all over h. I guess we're using t variables in here, but that's the same as your x. We're looking at a time of 1 second, so we can write this as f of 1 plus h minus f of 1 all over h. So doing that f of 1 plus h, we're going to take 1 plus h and plug it into our function here. So that's going to say 16 times 1 plus h squared minus f of 1, we're going to plug in 1. 1 squared is 1 times 16 is 16, and this is all over h. I'm going to look at squaring that 1 plus h, so that means we're going to multiply by another 1 plus h. So we have 16 times 1 times 1 is 1. 1 times h is h. H times 1 is another h. And then h times h is h squared. Still have this minus 16 on the back end. And this is all still over h. If we look at distributing the 16 in, 16 times 1 is 16. 16 times h is 16h. 16 times this other h is another 16h. 16 times h squared is 16h squared. And then we still have this minus 16 hanging out on the back end, and this is all still over h. If we look at combining some like terms, 16 and negative 16 cancel each other out. 16h and 16h gives me 32h. I still have plus 16h squared, and this is all still over h. We can take a GCF of h out of the top. So I'm going to write this as h times 32 plus 16h all over h. These h's are going to cancel each other out. So we get 32 plus 16h, but we're not quite done because we still need to do this limit as h is approaching 0 of this 32 plus 16h. Direct substituting the 0 in there, and we get a speed of 32. So the speed of this rock after 1 second is 32 feet per second. That's going to be it for this video. Thanks for watching.